angles. Okay. Now, we've done these right, so the focus of here, of course, is going to be the right triangle, which we've done, but basically all the problems today are going to be right triangle problems. So we're going to be dealing with a right triangle here. And for the purposes of my notes, x is going to be here, is left to right, the adjacent. Y is the hypotenuse up and down, and z is the hypotenuse. Now, it's not always true in regards to x being the adjacent, but in our problems right here, we're going to have this angle theta here, and this right here is going to be our reference angle. We, you know, this is also what is known as an angle of elevation. So if a problem refers to an angle of elevation, the triangle is basically drawn this way. And if we were to be talking about other problems, we might have it like this, and then x, y, and z. And of course, this right here is the angle of depression. Okay. Which they turn out to actually be the same angle, in regards to how we do these problems. Because if you were to draw your triangle here, this angle is right here. So the angle of depression is equivalent to the angle of elevation. That's just a geometric part. I don't believe I put any of the homework problems that really test that understanding. Most of the triangles are indeed drawn for you, but of course not all of them are. In these notes, x is the adjacent, but if your diagram is drawn differently, x may be the opposite. So I just want to point that out. Typically when we work on these problems, we talk about angles of elevation and depression, such that we have this type of image that goes right in here. The reason why we have that is because the sine of the angle, of course, is opposite over adjacent, which means in this case that the sine of theta would be, opposite over hypotenuse would be y over z. Cosine of theta is equal to the adjacent over the hypotenuse, which means that cosine of theta is x over z, or tangent of theta is the opposite over the adjacent, and therefore tangent of theta would be y over x. And once again, that is in the scenario that x is the adjacent and y is the opposite. As a reminder, we're going to talk about the derivatives of sine, cosine, tangent. So I guess I'll write in here the derivative with respect to, well, I don't actually, well, I'll do those a little bit later on. Now, we're referring to angles here, but we're still going to be dealing with side lengths, or time. So when I say theta is a function of time. X is a function of time, y is a function of time, and z is a function of time unless noted constant. Now, once again, if you identify your constants in a related rates problem, you're able to plug them in, because when you take the derivatives of those constants, you're going to get 0. And that can be something that is very helpful. So if one of the links, and now we have another variable. So we have x, y, and z, and we have theta. Now, we're going to be asking, what is d theta dt? What is the rate at which the angle theta is changing with respect to time? So that's the questions that's going to be asked in today's question. So what is d theta dt? Or follow me with this, you'll be given d theta dt. Okay, and you'll be asked to find one of the other ones. So whenever you're working with d theta dt, note that you're going to have to utilize one of the trigonometric ratios. All right, so it's not the Pythagorean theorem, it's not the area formula. Now, in your homework, I do throw out a problem. Like part A might ask you like a review question of like last night's, where you are trying to find like dx dt or dy dt. Or you're trying to find dA dt, the area, right? So you might get those problems, but then every problem includes some piece that it's going to either give you d theta dt or ask you to find d theta dt, which means you need to use one of the trigonometric relationships right here. And again, be careful that y is the opposite and x is the adjacent if you're just copying down these formulas from the notes. So if you copy down these formulas from the notes, they're only applicable if y is the opposite, x is the adjacent, and z is your hypotenuse. Another very important thing, units. The units for theta are radians. All right, so we need to make sure that we're utilizing radians in these problems. So d theta dt is radians per second, radians per minute, radians per hour. So the units for d theta dt are always radians per. So it tells you how much radians the angle is changing by either increasing or decreasing, because what happens with these angles is they might be growing or they might be shrinking. All right, so the angle may be getting bigger, and you can think of these as like there's a very good problem where you have a camera, and this is how cameras work. A really you know when somebody, if you were taking pictures of somebody who's playing like a sport, and they're moving it fast across your field of view, and you get that blur if they're moving too fast. That's because cameras have a set d theta dt that they're capable with to be able to take their pictures. So if the rate of change of the angle at which, because it takes from when they first take the picture to it finishes, there's movement. So they can capture if that angle of change, within milliseconds, even that's their time period, doesn't go beyond a certain threshold, and if it does, you get that blur. Cheap cameras, even if something's barely moving, right, you get that blur because it has a very low tolerance for the rate of change of the angle. And more expensive ones have those very fancy features where they really are able to get a very high d theta dt's. And you'll see a problem in practice where you were going to try to find the theta dt and see that if the camera comes into focus or not. I was going to assign that problem in tonight's homework, but I figured I might actually put that, I deleted that off the homework just to make the homework a little bit shorter. And to give you that as a kind of a review question at the end. All sides variables. So when I'm doing that lately, I don't want to put a question mark. When all sides and angle are changing at a constant rate, not that are constant, but a constant rate, then product slash quotient rule required. Recommend recommend rewriting so as to use product rule. So it's not the only way. So you can do the quotient rule. I just find that it's actually a little bit, there's a lot more mistakes made with it. I'm not a big fan of it. So I typically go with the product rule for all problems. And you'll see, and so the way I'm going to do it right now, I'm going to do the derivative for each of these functions, kind of like how I've done them for you in the past, and I'm going to find the rate of change formulas for each of them when every variable is changing. So the formula, rewrite formula, rate of change formula. So let's look at the first one. The first one we'll look at is sine, the one that you will probably use most often, or that we like the most. Sine of theta equals y over z. You could take the derivative like this as is, and then requires you use the product rule or the quotient rule. I'm not a fan of that, like I said, so I'm going to rewrite this as z times cosine of theta equals y. This is how I like to do it. It is not the only way to do it, but it's the way that I'm going to be doing it in my notes and how the way I'm going to be doing it when I work with help individuals, okay? And I just realized I need more room here. All right, so my derivative is a product rule where z is u and cosine of theta is your v. So the rate of change formula would be dz dt times cosine of theta. All right, that's the bracket right there. That's the derivative. Plus the derivative of cosine of theta. Now, what's the derivative of cosine of theta?
Negative sine.
Negative sine of theta. But remember, we're taking the derivative with respect to time, so it would be times what?
Cos theta.
No.
I don't remember.
You don't remember because I haven't taught you. I'm saying it's not a remember, it's an application. So it's just, remember, we're taking a derivative with respect to time. So it'd be negative sine theta times.
dc dt.
There is no. D theta dt.
I didn't data. Really?
You what?
I need the data.
We're not adding a theta. No. The theta
So
is
it's
a,
not d data over dt.
it's d theta dt.
Yeah. I say so. I don't have any idea adding the data.
I don't even know what you're saying. Um,
No way.
so negative sine theta, and then the chain rule portion of it is times d theta dt. Remember, whenever we take a derivative, we're always going to have that d dt. In the first problem, it was just z, so dz dt. In this problem, it's theta, so we have times d theta dt. It's going to be this times what? Product rule. Need somebody. We're going to run out of time here. Product rule u prime v plus v prime u
So it's negative sign.
So u prime v plus v prime u, so times what? So negative sine of theta d theta dt times, what is that? Z, yeah, just a z. Equals the derivative of the right hand side, which is?
Why?
No, the derivative. What's the rate of change for y? Come on, people. What's the derivative of y with respect to time?
What?
No. What's the derivative? There we go. Thank you, Mana. She likes to say it in the background. dy dt. Just a dy dt. The derivative of y with respect to time is dy dt. So when we take the derivative in these problems, what typically happens is you are going to be asked to find this. So this is what we're going to want to find. All right. Now, that means you'll need to be given all of these other pieces of information, or it might just turn out to be that the rate is zero. For one of these, like this might be zero or this might be zero when you plug in all the values. So it's a plug and chug type problem in the end. All right, next one. Cosine of theta equals y over z, or x over z. All right, when I want to do this problem, I want to rewrite it. So when I rewrite it, I get z times cosine theta equals x, and for the most part, it becomes much the same. Oh, I, what in the world did I do? What in the world did I do? I had totally, and no one really caught this part right here. Um, I really flubbed that. Please change. So actually, I'm doing these. Oh man. Okay, it's an easy fix. I don't know where my mind is right now, and I'm sorry, I apologize. This one should be cosine theta. Hopefully that was the reason why you were like, what the? So cosine of theta, all right, and that should be an x right there. So that's an x, and then that's an x. So sorry about that. I when I went to the next line, I changed the sign to a cosine. Like I don't even know why I changed the sign to a cosine. So sorry. So now we'll do the sine of theta equals y over z. So z times sine of theta. Where is my mind going? Equals y. That was really weird. All right, product rule on this one. So U is the Z, V is sine theta, so we get what? And if you need to collect yourself in terms of my terrible mistake there, everything
DC
dz dt times
sine
of theta plus
cos the data,
cosine of theta
cosine data,
times
d data over dt
d theta dt
times c. No, that y. Sorry, I confused. I know. No.
times
T.
z. It's just all we're doing is the left hand side equals
dy dt.
dy dt. And then the one that's usually the trickiest, and it's not necessarily the trickiest because of the derivative, because it's just a rule of memorizations, but when we actually plug in the numbers, it might be a little bit tricky to you. That is, of course, tangent of theta equals y over x, which when I rewrite it gives me x tangent of theta equals y. So in here, I get what? Take the derivative. Let's take the derivative.
dx over dt
Dx dt times tangent of theta
Data
plus
plus sec squared
secant squared
secant
of, remember that you guys, you cannot just say the trig part. You need to finish it up. Secant squared of theta times,
d data over dt
it's not a fraction. I keep trying to fix you guys that. D theta dt times
x
equals
dy dt.
dy dt. Now, this is the same thing as dx dt times tangent of theta plus d theta dt times x over cosine of theta squared equals dy dt. All right. Now, the reason why I'm doing it that way is because typing in secant squared gets a little bit complicated. So when you have to plug it into the calculator, you just bring secant squared. When it moves to the denominator, it's cosine squared because secant is just 1 over, secant of theta is just 1 over cosine of theta. So secant squared theta times becomes divided by cosine squared theta, or cosine theta squared. Now, we're going to be utilizing your calculators. So I believe, and I got to double check, and I might be just having to do these problems over. I don't want you to try to utilize the unit circle. You can. It actually becomes very helpful. So, you might see the idea here is that we're going to need to use decimal values in order to track our work and plug in. Now, evaluating sine theta, cosine theta, tangent theta. There are two types of problems that are going to be given. One of the problems will tell you the actual values. So they might say, for example, this is y, x, and z, and they may tell you that these numbers are like 3 and 4. All right, and therefore z is equal to the square root of 3 squared plus 4 squared, which would be 5. That's kind of like how you would be given these values, and therefore sine of theta would be 4 over 5. Cosine theta 3 over 5, this is like an example, and tangent of theta would be 4 over 3. So that's one of the ways that you do it. The other type of problem that is given is you're given the triangle and they tell you what the angle is. So they might say something like this is 30 degrees. All right. Now, most of the times they're going to give you these. I know where I said radians, but when we evaluate them here, when they're given in these values, we can plug in the degrees and it'll work the same. We just need to note that the units for the rates are going to be in radians, and they might say something like this is 4. All right. So which is the y, this is the z, or sorry, this is the x, and this is the z. So when doing this, if you need to figure out what is x, and I meant to do this as a different color. And you want to find x, well, you want to find sine of theta. Actually, you wouldn't even be given any of the side lengths. You want to find sine of theta. Sine of theta is simply sine of 30 degrees. So you actually type this. Now, I believe, let me just double check the homework. You need to figure out, I need to plug in now. So you just plug in 30 degrees. And then when you evaluate everything, you need to make sure your calculator evaluate in degree mode. So let's do a couple of examples. I'm going to jump the page. Okay. Very traditional problem right here, and I think you might even have one on your homework. A rocket is launched upward at a constant rate at 100 feet per second. A radio station is located 300 feet from the launch site. And tracks the rocket. So you've seen this type of problem with basically we've done this type of problem in your homework, I believe it was, and I asked you for like a dy dt dx dt. Okay, so let's do that type of problem first. So question A: how fast is the distance between the radio station and rocket changing when the rocket is 400 feet high. It's the instant the rocket is 400 feet high. So it's all about that diagram first and foremost. So let me pause it real quick right here while you copy this down and we go forward with this problem. It's a very traditional problem. So right here we have the radio station. Over here we'll have the launch station or the launch site. And over here vertically we have the rocket. And so as I informed, we have a right triangle. We'll label the sides X, Y, and Z. And the first thing that we want to do in terms of labeling is firstly identify anything that is constant. Are any of these variables constant?
Is it X?
Yeah, X. X is 300. This is constant. The radio station does not move left and right. The launch site does not move left and right. That is 300 feet. 10 hours later, it's 300 feet between the radio station, like a building and a building. The distance between two buildings will be 300 feet for always and forever. The rocket, though, is going up. So the rocket is shooting up. So that means that y is a function of t, and z is therefore a function of time as well. Next piece of information is what do they tell me and what do they ask for? So what else? What other information do they give me? First thing, if I read the sentence, the first thing is 100 feet per second. What is that?
Is it Y?
It is not y. I can tell you it's not y because it has per second. It is dy dt. There you go. Dy dt is 100 feet per second. We already labeled the x as the 300, so they've already given me that piece of information. And what other information did they give me? Well, come on, class. Just look at the next number.
400.
400. And what is 400?
This is Y.
That's y. So, all right. And what is the question asking me to find?
How is the distance between the radio station?
So what are they asking me to find? Thank you, Ariana. dZdt. All right, they're asking me to find dZdt, the rate of the distance between the rocket and radio station. All right, so we're not dealing with any angles in this problem. This one is a review. So we're going to utilize the x squared plus y squared equals z squared. I am going to be plugging in any constants. So I get 300 squared plus y squared equals z squared. And now I'm going to differentiate 2y dy dt equals 2z dz dt. and the 2's cancel each other out, which will help me in plugging in numbers. All right, they're asking me what is dz dt. I know dy dt, I know y, but I don't know z. So this is when you have to do that extra little sub problem. I need to find z. So how do I find the value of z? The Pythagorean theorem, perfect. So 300 squared plus 400 squared equals z squared. And this is what is known as a Pythagorean triplet. It's a 3, 4, 5 Pythagorean triplet, or a proportional to that. So this is nice and easy. I'm just going to jump to the answer. Z is 500 feet. And so now I have Z. All right. With that, I plug in. This is just a review homework. This is nothing new. This is everything right here we've done so far in this problem is basically what you should know how to do because you've done multiple problems like this. So I plug in y, 400. I plug in dy dt, which is 100, equals I plug in z, which is 500, and then dz dt. Most of the times I'll be asking you just to input your answer as a decimal so you can just plug in the numbers. But, you know, when we solve for this, you know, you divide by 500. And we get dz dt is equal to 80 feet per second. And that is my answer. Nothing new there. And we're kind of closing in on time here. All right, I gotta get moving now. What time does the class end?
9:49.
Like 49. All right, I gotta fly because we took too long to respond to that one.
You want to remind us?
B. How fast is the angle of elevation changing at that instance? So we're just following up with the same picture. So all the information is the same. We have every piece of information that's going. So we're going to assume we don't know what dz/dt is though. So in this problem, x, y, z, the angle of elevation is right here. Instant. I don't know why I said instance. We know that this is 300. Always use constants. Okay. And we know that y is 400 feet and dy dt is 100 feet per second. So because I know dy dt and I know x is constant, I'm going to use the relationship between x and y for this problem. So the trigonometric relationship for x and y is that tangent of theta is y over x. But x is constant, so tangent of theta equals y over 300, which makes the problem a lot easier. I'm going to rewrite that, of course, as 300, just to utilize the same way I've been doing it, 300 tangent of theta equals y. Okay, so I plugged in the constants. I know we're running out of time. I just plugged into 300 because 300 was constant, and I used the relationship. Now I take the derivative. The derivative doesn't even require a product rule. It's a nice derivative. I get 300 secant squared theta d theta dt, don't forget that because that's what we're looking for, equals dy dt. Okay. Now, as I told you, we want to find d theta dt. So I'm just going to solve for d theta dt. D theta dt is equal to, now, when I secant squared over here, I would multiply by cosine squared. So I'm going to get dy dt times cosine of theta squared. Goes on the opposite side. That's just, making the math easier, over 300. All right. And therefore now I'm going to plug in. So I know, and I'm almost done, I know that dy dt was 100. And cosine of theta, if I look at that picture, remember, I already know that z is 500 now. I do know that z is 500 now. So what is cosine of theta? Cosine is the x over z, so cosine of theta is what? Well, I don't have time. 300 over 500. All right, now we just plug everything in. So d theta dt is equal to 100 times 300 over 500 squared, all over 300. And I don't have a calculator for that. Those all cancel each other out. So that's 9/5 divided by 3, which is 3/5, which is 0.6. So d theta dt is 0.6 radians and per second. The trickiest thing here was this idea of the secant squared. Basically, I canceled that out and I wrote that as cosine squared theta. And then when I bring it to the other side, it moves into the numerator. You'll get some practice tonight, but most of the things stay the same. You take the derivative, you plug in the information. The only difference here is that the formula you use is a trig formula, and when you take the derivative of that trig, you get a times d theta dt. There's some really good problems. Practice it as best as you can in doing these types of problems. I suspect there would be, if there is a free response question on the AP exam that covers related rates, it'll be a right triangle problem such as this, where you're asked about the dy dt, dz dt, and you're also asked about a d theta dt. I'll be available during office hours, of course, and there's also tutoring as much as I can do during this class time period. See you tomorrow.